Sending data. And we are live. Hey everybody, welcome to the first debate night against Shawn Hawkins and Leake. The topic for discussion is got to do with space and navigation. Thank you, Brian and Shawn, for coming. How are you guys doing this evening?
Good.
It's good, Brian.
Yep, all's well. All's well.
Okay, thanks everybody for joining in chat. Really do hope you guys enjoy it. We are going to have an epic discussion. Please do note that Q&A will be after everything. All super chats will be moved forward to the queue for chats. So yes, we're going to start with 10 to 15 minutes openings, and then 5 minutes rebuttals, and another 5-minute rebuttals, and then 20 minutes to a half an hour open discussion, and then obviously the Q&A. So who's going to start it off?
I think I'm starting, right?
Okay, cool. And off to you, Shawn, for your 10 to 15 minutes opening.
Okay. Is my screen? I'm sharing my screen.
Yeah, it shows on my side.
Okay. How do I? So YouTube's delayed, isn't it?
I think
Yeah.
YouTube's a bit delayed, yeah.
There we go. Okay, I see it. All right. What I have here is GeoGebra. This is my angle to Polaris presentation. As you can see, it's 90 degrees above the North Pole. 90 would be North Pole. And here we have the equator. Marked as E, how about that? I didn't even do that. And when you move, for every degree you move, it's 60 nautical miles. Right? So when I move 10 degrees out, the angle should match the number of latitude lines that I've moved. For instance, if you go 89, which would put it about, you can't see my cursor, can you? Well, if you look at point M, it's at 80 degrees latitude. You're looking up at Polaris. But somehow the angular measurement is 77.5. Here you are at 60 or 70 degrees latitude, and it's 66.1. Here we have it at 60, 56.4. See, the numbers don't match. It does at 45 degrees latitude, because that's a right triangle, and the two legs on a right triangle match distance. But the problem you get into is around the equator, you got 26.6 degrees latitude. That's not what we observe in reality. Now you can put this anywhere you want, and it will not match. The numbers won't match. Ever. Put it all the way down here if you want. But of course, if you're seeing Polaris at, I don't know, 1 degree above the horizon, that means at the North Pole, Polaris has to be this high above your head. We don't see that. The only way it works is on a sphere. And I've presented that in my angle to Polaris video. I could show that if you need. But I think we've seen it, haven't we? But it's pretty easy to find. Should have had it already called up. Videos. Yeah, here. See, the only way it works is on a sphere. when you wrap that flat surface around a curved surface, all the numbers line up. All the numbers point to the same place in space. Polaris, which is huge, a lot bigger than the Earth. As a matter of fact, Polaris is actually 3 stars in a group that are so close together. The Rayleigh criterion, the angular resolution is so low that it just blends into one star, but we still see the light. So all these would be pointing at the same place. Now you say, well, they aren't. They're parallel. They're all pointing to different places. No, they're all pointing to the same star. If this was a perfect model, see if we can get a bit more zoomed out. Yeah, that's a little better. If it was a perfect model, these would not be perfectly parallel. These sticks that I used in the model would not be parallel. They would be slightly angled toward each other, but at an angle that's impossible to measure because of the distance. Think of it as slope. You have millions of light years. Was it 4.3 million light years to Polaris, something like that? I'm not sure. I'd have to look it up. And then you've got the Earth that's 6,000 miles wide. Yeah, that take half of that, it's 3,000 miles. The rise to run factor on that is so small you can't measure it. So for all intents and purposes, it's parallel. So it doesn't matter where you put the star, how high or how low, the numbers do not match latitude on a flat Earth. I also have this. This is, what was this? Oh yeah, this is the sun. We've got the sun at about 3,000 miles overhead. Here's this line here. The line starts at D, goes through B, and extends out. That is the horizontal path that the sun would take on a flat Earth. So we take the sun and we move it along that path. And see, the angle never drops to 1 until you get to 48,000 miles away, or 480,000 miles away. How big is your flat Earth? How big is the circle that your sun takes on flat Earth? Here's GeoGebra. This is Karen V's illustration for the personal dome, the perspective model. And you've got the sun moving across the sky, as signified by the top line with C through D, with TSR, see the top dots. And then we've got the perspective angle dropping down. And the problem is, it doesn't matter how far away the sun gets, or how far the sun gets, you can never make this line intersect, right? You got you looking at the sun, but when it sets, it's below your eye level. So you've got to look down. And then once it sets, if you traced it with your eye, you'd see it here, right? The ground is gone, you'd see it here. The problem is, how do you connect you with the sun when it's below your eye level and this horizontal line above where it travels? Kind of impossible. And for my last thing, I got 2 more things. This is an example this is the source code from Stellarium. You can take a screenshot, but get heliocentric ecliptic position is the first line of code here, or third line, I guess. It calls for the heliocentric elliptic position of stars and planets. And here's another page out of it. So Stellarium was designed using the heliocentric model. And it matches reality perfectly. Now, if I took plans to build a truck and I put those plans into use, I would get a truck. I wouldn't get a Volkswagen or a bus. I'd get a truck. And for the last thing, here we have a line. Each one of these lines here is 10 miles, or 5 miles. 5, 10, 15, 20, 25, 30, 35, 40. So this is 100 miles. Represents 100 miles. And it's flat, ain't it? Until you zoom out and you realize that it's 4,000 mile radius circle, or 3959. So exactly when you say that, well, I should see curvature standing on the beach looking at the water, how curved do you think the Earth should look with a radius of 3959? So, of course, it's going to look flat, because that's how big a curve that big looks, or that's how curved, or how flat a curve that big looks. So, I think I'm done. Oh, one more thing. I modeled sunrise and sunset on a flat Earth using Blender. And goes on for a little bit. Yeah. And what I got was this. This is what the sun would look like on a flat Earth, making a circle overhead at approximately 3,000 miles overhead. Now, this is if you were at the North Pole looking at it. And there's no reason why we shouldn't see it at the North Pole on a flat Earth. The sun would never set on flat Earth, ever. It would never be dark on flat Earth. Geometrically impossible. So, that's it.
Okay, nice. Thank you, Shawn. Thank you, everybody, for coming in. If you haven't already, just know for the Q&As, all super chats will be moved into the list in the front. So yeah, welcome one and all. Brian, are you ready?
Indeed I am. I just wanted to say, man, I could probably shut this argument down quicker, but I'm gonna beg the question, be a good sport tonight, and I'm going in model afflicted, man. Let's do this.
Do you want me to show the YouTube video, or are you going to show it yourself?
Yeah, sure. If you could show it, that'd be great.
Okay. I hope everybody can see it. I'll wait for the delay to come and then I'll start it for you. Should I put the sound on, or?
Yes, absolutely.
Okay.
I already debunked that. He lives close, Crow 777, or whoever the guy was that did that. He lives near an airport, and you can time the times that he takes his lunar wave photographs. You can time it to planes taking off. I gotta
live next to an airport. Okay, you said Crow. I debunked Crow. He lives next to an airport. You can time the planes taking off. You just blab bullshit, bro. I'll rest.
The moon is waving. It's this.
Do you know where Crow lives, Shawn? Shawn, you led. Anyway, you led with. He lives next to an airport. Do you know where he lives, Shawn?
No, I don't know where he lives, but
I debunked that. He lives close, Crow 777, or whoever the guy was that did that. He lives near an airport, and you can time the times that he takes his lunar wave photographs.
Rests on you.
You can't answer the question.
The burden rests on you, Shawn. Do you know he lives next to an airport?
No.
Okay.
Then leave with he lives near a fucking airport.
More than likely, he lives next to an airport. See, Brian has a hard.
So let's focus on the number 2 boxes. Above each number 2 box is a Polaris. So the middle number 2 box represents a guy standing directly underneath Polaris, 90 degrees. The left number 2 box represents a guy 45 degrees at Polaris. So they all have their own Polarises. That's how it has to work on a globe. So if you have two guys standing 1 mile apart, then they're looking up.
That seems to be buffering. Not sure why. Hope everything's still going. Doesn't even want to play the clip. Can you hear me, Brian?
I think it's going, man.
No, on my side it doesn't want to play anymore. It just stopped. Let me try.
Damn, that didn't have nothing to do. The only part that played was the part me just mucking with Shawn a little bit, man. That didn't really have nothing to do with my presentation. I was just poking him a little bit. Let me see if I can share screen, man.
Yeah, I think it might be better because it.
A mile apart.
Okay, that's working again.
And they're looking up at their own little spot in space at their own Polaris. Shawn is going to complain that we have to move Polaris to make it work. Look what the globe has to do with Polaris to make it work. You can have two men on opposite sides of the Earth, 1 degree below the equator, simultaneously looking at Polaris on the horizon. I'm going to show you the ridiculous amount of refraction that requires, and he'll still probably complain about my refraction model. So if we just give him the benefit of the doubt and put Polaris at 1 light year away, there'd be 101 billion miles of refraction simultaneously happening on each side of his ball. That's the type of refraction the globe is dealing with. So I'm going to beg the question with Shawn tonight, and I'm going to first show him
what the fuck?
Their ridiculous proof of refraction, and then I'm going to show my model of refraction. So what I'm showing here are examples of real life refraction and not just faceless assertions. The guy has a direct line of sight and he opens the warehouse door and lets a little cold air in, and he closes it and we see the white light disappear first because it's the lowest, and then we see the green light disappear next, and we see the toys cut in half. Okay, these are real life examples of refraction with a little temperature manipulation. Okay, they claim that the light refracts downward, but every time we look at a laser side on, we see it bending upward. Okay, all the globe brings is lasers and sugar water, and that also proves our model, and I'm going over that later on. So we can match real world observations over direct line of sight observations at a couple 100 feet, little flat bodies of water. So I have modeled the way I believe it to work with refraction over a flat plane with a ratio as a function of distance, which I'm going to demonstrate. So until my opponent can show light refracting downwards, all of his claims are nothing more than baseless assertions.
Only happens in the atmosphere because the air is denser lower down. So you should see the light curve downwards, and we should, looking at this end, see more of Chicago from this end. So let's see what happens.
This is Mick West using sugar water in a fish tank with a laser to try and demonstrate refraction in their model.
Hey, was y'all able to hear that? My phone is freaking out all of a sudden.
Watch all the great links he goes through to try and
freaking out. Was you able to hear that when I played?
Pay attention to the antenna on the biggest building.
I'm getting no audio.
So let me see here. We see the same view of Toronto that we saw before.
It is magnified, of course,
Let me
but
try again.
it's not distorted in any way. The image is exactly the same. It's just bigger because we're looking through the water.
So I've got about
So we
6
see the big building with the antenna obviously doesn't line up. The shadow on the bottom doesn't line up. The little leaf right above that doesn't line up. But look what he's done prior to filling up the right side with water. Look how much smaller the buildings are compared to the left side. So he's put in a lot of work doing this deception, and he's got a plate on the bottom that's curving, depicting Earth curve, and he literally has to change that to get away with changing the angle and the elevation of the camera. So watch this mid-fill edit. You'll see the shadow and the little leaf-looking thing move, and the background staying the same. This is a joke.
Because, but it's not distorted in any way. But it's not distorted in any way. The image is exact.
all that work he put in to get the height of the building and the size of the building to line up
Hey,
after compression.
can I cut in for a second?
Give me a break.
No,
So
sorry.
here they've added the sugar water, and
Yeah,
look, he just proved
Sean.
The only way I
refraction
could
over
hear
flat
it was
plane.
listen
Look,
to it on
he
YouTube,
lowers
and I
down.
had
Remember that
YouTube
black rim
muted
down at the
about
bottom
halfway
represent-
through the presentation after the moon wave. So I wasn't able to hear the audio. I could gather what he was saying, but
Okay, yeah,
Sorry.
because it did freeze
Didn't mean to
for
interrupt.
a while, so it has to catch up. But I know
okay.
he's halfway in with his presentation.
All right, I'll just listen.
Okay, sure. Thanks.
You're playing it right. You're playing it right,
And we
Flat
lose
Sword?
resolution.
Yeah, it is playing. You are about 5 minutes 56 seconds in.
Yeah, I just couldn't hear it through Skype.
Yeah, it's playing.
Yeah, you might.
You might have to watch it through YouTube. That's why I said it might have been
Yeah.
easier if he shared the screen. But I think for the audience, they can hear it properly through YouTube. Should I wait a few minutes so you can get back onto YouTube, Sean?
Yeah, just go on YouTube.
Yeah,
real quick, Sean.
I think we're good.
Are you sure? Okay,
I think we're good.
so I can carry on. Okay, I'm gonna start again. There we go.
But we still have line of sight because there's a black rim all the way around the fish tank. So we never lose line of sight, yet half the city's gone. Like, I don't know what he thinks he's proven, but I mean, granted, I did slow it down. But, you know, this is just compression. Now, look, see the lasers off to the side? I'll show it hits the side. So he moves it over to the middle to try and get it to bend around the ramp. I don't think it'll bend around the ramp because, look, he tries to do it, and I stop it, and it just hits the ramp. And why don't you show us if it bends around the ramp? Okay, look, that's on the side. He gives us a side view, and I slowed this down, or it wouldn't be so easy to see. Look at the light shining, hitting beside the ramp. Are you kidding me? Why would he have to do that? Then next, he says with his own words, he's simulating a laser. It's coming in from the top, I think. But look, he's just proving refraction on a flat plane. Look, we lose resolution of the ground as the compression takes effect. We never lose sight of the light until we lose the line of sight. So, welcome to Flat Earth, Mick. All right, we're going to test 69 miles per degree on a flat plane. So, we're almost directly underneath Polaris. We put in 89 degrees. That puts us 1 degree away from it. And we put in 69.1 degree for our baseline distance. And let's see our height to Polaris. And what do we, whoa, 3958.7, the exact globe radius. So now we know how they determine their fake radius by using flat plane trigonometry and putting it to the center of their model. So it's not a coincidence. So let's do twice 69.1, so 138.2 with 3958 height. And look, 2 degrees, 88 degrees. So it's still good. Let's try 3 degrees. So 207 miles baseline distance. And look, 87 degrees, still good. Let's try 10 degrees. So 10 degrees is 691 miles, 3958 height, and look, 80 degrees. So 69 miles per degree, still holding firm. So 15 degrees, we put it at 1036 with 3958 height and 75 degrees, still good. So let's try 20 degrees. 1382 for our height. For our distance. 3958 for height and 70 degrees. So you have to go almost 1,500 miles before it's even off by 1 degree. So in that distance, anything could happen, but just all we need is a little refraction. So I've made a formula. So if Shawn asks for angles to Polaris on a flat plane again, just remind him of this. 90 minus A over 90 times D times point A minus 1/2 A, where A is the measured angle and D is the triangulated flat plane distance, and point A minus 1/2 A is the ratio of refraction. So this is all real measurements and real calculations, no fantastical radius and no arbitrary bullshit 7/6R. This is real measurements, real calculations. We're going to put it to the test. So in this example, we measure 30 degrees to Polaris. So 90 minus theta is 60 degrees. We put that in. We put in our flat plane triangulated height to Polaris, which was 3958, and we calculate. So our distance, or D, comes out to 2285.7, and our A is 60.
It caught me off guard. I didn't think you were actually going to have some numbers. That's great. Hold on. All right, what do you have? Go ahead.
Okay, there's what I think you're looking for is, let's see, 29 degrees, 40.5 north, 36, 57.0. That's got to be within a few miles.
That is certainly within the parameters.
Had a pull. So we're going to go 90 minus 60, which was 30. So 30 over 90, which is 30 divided by 90, times our calculated distance, D, which was 2285.7, times point A, so times 0.30, minus 1/2 A, which is 15. Gives us 213.5. That's our refracted value. That's what we have to subtract from our calculated distance, from our triangulated distance. So we're going to take 2285.7, and we're going to subtract our refracted value of 213.5, and we get a total of 2072. We're going to divide that by 30 to see how many miles per degree we get, and I'll be dipped in shit. 69 miles per degree. So if you think my formula is crazy, this is the first thing that comes up when you Google the Haversine formula for great circle distances in navigation. And look, it begs the question with R. So you can't do nothing on the globe without a pre-assumed radius. Okay, but the main point in all this is that even if I could get my formula to work exactly perfect, that doesn't prove that that's the type of refraction that's going on. It's just math. It's just a model. I don't even think this model's right. It looks like it's using radians and depicting degrees, but anyway.
Here's a little known fact. Even though the moon is 1/4 the size of Earth, 2 Earths can fit in the biggest crater on the moon.
Is that all, Brian?
Almost.
Because it was at the end of the video. Yeah.
Yeah, that was it.
Okay, and if you guys are happy, and Shawn, you're probably still listening to the last few minutes on YouTube.
Yeah.
So while you waiting for that, I'm just going to quickly go to comments. Hi everybody in comments, thank you for coming. Please don't forget to press that like button and share the show to get out to more people. I just wanted to thank you to the debaters for coming again to debate. So far it's been quite awesome information shared from both of them. I do think we all agree. I have put a poll up. Let's see what the poll says so far. Who has the better arguments? So far, for 90 votes, Brian Leake is 21%, Shawn Hawkins 78%, and they are equal 1%. 92 votes, quite a hectic amount. Yeah, so thank you all for coming. Please just don't forget to hit that like button and share, as it does get it to more people. Yeah, I'm not sure if Shawn's ready yet.
Yeah.
You're ready? Okay, so we can go on to 5 minutes rebuttal from Shawn, and then we move on to another 5 minute rebuttal from Brian. If you're ready, you can go.
Okay. Yeah, as you saw by my GeoGebra presentation, the sun could never approach 25 miles or 25 degrees above the horizon. If we go by the David Weiss app model of the Earth as a round disk with the sun, circling overhead at the equator and the tropics, the angle it would be at would never hit 26 degrees. you need refraction to be relevant at like 25 degrees or lower. So the sun really wouldn't, the sun, the stars, whatever, or Polaris would never approach that 25 degrees needed for refraction to be relevant. So your calculation for refraction is not relevant. It doesn't, the sun would never, or the sun or Polaris would never be in that zone to be refracted heavily. That's all the rebuttal I have.
Okay, so you want to forfeit the rest of your 5 minutes?
Yeah.
Okay.
Yeah.
Up to you, Brian, for your 5 minutes rebuttal.
Okay, I think Shawn voted for himself, man. Just putting that out there.
No.
I wanted to say you're missing a whole big deal of my whole entire topic, I believe. I don't know if you were able to hear it, but the globe claims downward refraction, okay? And one consequence of that is Polaris is seen simultaneously, can be seen simultaneously 1 degree below the equator, antipodal at the same time. So the amount of refraction that requires is, and just this is just considering the sun. I mean, the Polaris is 1 light year away. You would have about 100 billion miles of refraction simultaneously opposite on each side of the globe. So you've definitely got issues, okay? And I think any model is going to have issues. So if I can share screen real quick, Flatsoy?
Yeah, perfect. You can go.
Just to address what you just said, because I was having trouble with the YouTube audio during the space doesn't refract. Space is consistent, empty void. You would only get refraction within our atmosphere. So the distance that Polaris is away is irrelevant when you're talking about refraction.
Okay, we'll get to open dialogue next. Let him do his 5 minutes
Okay.
once you're finished.
All right.
Sure.
Yeah, I'm muted.
Cool. You coming okay there, Brian?
Okay. Yeah, I'm just gonna explain it for Shawn instead of trying to do this, man. My phone is, I don't know, it's never ever did this, but anyway, so what I was showing Shawn is Pebbles on the Pond video, and he is on a warehouse floor. So what I'm gonna describe to you is a bunch of real life examples just in regular atmosphere. No sugar water, no liquid butane. We can demonstrate in your model, light is said to curve down because of dense or medium. I guess they tying in pressure with density at ground level. But anyway, the Pebbles on the Pond, I think it's 100 feet. He has line of sight to 3 lights, a white one, a green one, and a red one, the white being the lowest, green being the middle. And he opens his warehouse door for about 2 or 3 seconds and then shuts it, just letting in cold air. And the white light disappears first, and the green light disappears second. And then the red light is a little higher, so it never disappears, okay? And then I showed about half a dozen laser experiments with a bit of a side-on view, and they're all curving up. They're all curving up. They're all doing exactly what the globe model, they're doing opposite of what is said. And then I showed Sky Free on a little pond, just showing little boats, match observations we see out at sea on some days, because some days the horizon is indefinite, like a black swan day especially. But then some days we have more refraction, and we can get sinking. Okay, I've seen it. And Pebbles on the Pond, Sky Priest, shout out to all these guys, was able to replicate it, like I said, with just a couple hundred feet on a little pond where earth curve was only like a millimeter, not enough to affect the observations. So I played that in my opener. And so all of these real life observations lead us to question what we're taught with 7/6R, with refraction in general. But ultimately, my main point is I showed the one example we get from the globe, and that's the sugar water, the laser in sugar water. And Mick West demonstrated perfectly. As long as we had line of sight to the green simulated laser, we never lost vision of it. It's not until we lost line of sight that we lose vision. Yet the building compressed. He literally showed compression. He was with line of sight, so he showed you how it could work, and then eventually with that compression, which is what I'm putting as my refraction model, is that refraction needed to basically finish the compression, finish the job. It's just a formula. It's a function of distance based on what we see, based on real life examples. And I think what's causing it is a humidity gradient. I don't think there's enough pressure difference to cause any kind of refraction, except for the difference in medium, I think, is mainly what causes refraction. And we have a medium with a lot of moisture down low, and water vapor is less dense than air, the air above it, the colder, denser air above it. And I think that's what is not being taken into account. And that's why I modeled it. So I just come up with the model to explain your 69 miles per degree. All right.
Okay. Okay, so back to 5-minute rebuttal for Shawn. I just have to quickly, so Bob from Globusters, I have no control over the polls, so please stop making baseless assertions and attacking me. I'm just the moderator here, and I'm very not having any bias towards anybody, so if you don't want to be nice to anybody here, then you don't have to watch. Up to you, Shawn, for your 5 minutes.
Yeah, where the sorry, I had to clear my throat. With the warehouse where he opens the door, called the temperature inversion. When you have colder air above warm water, the light will reflect up or refract up. That's commonly known in physics. And all the other things you're talking about, that's understood physics. It's physics that are known, quantified, of refraction. So I really don't know what your argument is.
You want to?
That's all.
Just give me like a couple minutes, and we'll just go into back and forth. I'll try and make it short. I think that. Sorry, go ahead, Flattoy.
No, I'm saying nothing.
Okay.
Remember, Shawn's with these 5 minutes.
Go ahead.
Yeah.
Okay, I think that the quantification is within the model. Sure, you've mapped it to make it work. Like the main surveyor tried to replicate Alberuni, okay, and he measured like 20 million feet for the radius due to his calculations. He was off by 7 million miles, okay? And NASA has papers showing that when you get up to half a mile and higher, there is no definite horizon. So what I want you to show me something being blocked from a big height, from like an airplane or something. I don't think you'll be able to do it. I may stand corrected, but I think NASA's paper is right when it comes to that. But so within the model, the quantification works because, but how does light know the size of the radius? So they're using 7/6R. That's basically, multiplying 1.1 1/6 times 3959. So in essence, you're making the ball bigger. How does light know the size of the ball? It's just a mathematical, abstract, basically ad hoc model. So yeah, the numbers are going to fit. But I want to see a real life example, like where I showed you all them different lasers. from a slight side view, they're all bending up. So if light's supposed to be bending down, you should have no trouble showing me that in real world conditions. With maybe just a little, you say the cold air is causing an inversion, but I think the cold air is coming in from down low. And I think it happens in multiple weather situations. I think the Plain Truth, shout out to Travis, did a good job showing that it's not as predictable as we once thought. There's things that need to be updated, studied to update the science, in my opinion. And nobody seems to want to even look at the evidence when it's just glaring and all over the place. So that's my main point.
Okay, so if you guys want to go to open dialogue, I think we've already started it though. So yeah, I think let's do 20 minutes to 30 minutes open dialogue, if you guys are happy with that.
Sure.
You want to just go ahead and concede, Shawn? What do you say when I ask for evidence? Like the lasers I showed you and the light vanishing. Can you show me light? Can you show me literal light refracting downward, not the effect of it, but the actual light, like I showed with the lasers? Is that possible?
I've never done that. No.
All right, because we were asking for examples of looming, and that's kind of what it would entail, is if the light, this is what they claim, if the light refracts downward, bends downward, and it would make things appear to be higher. And this is how they explain the black swan, which is an observation, where we
the black
see
swan.
Yeah.
So let's talk about that a little bit.
Well, yeah, but let me finish real quick. That refraction is used to explain pictures like that and other black swans, so I don't know which black swan you want to talk about, but it's just a model, man. But go ahead. I'll back off.
Yeah. Does the size of a planet change with the weather?
Can you repeat that, please?
Can the weather make the size of a planet change? Does the size of the Earth change with the weather?
I don't think it's a planet, so I would say no. And nobody will ever know the entire size of our world, is my opinion, if I'm being honest.
Well, it's been measured, but for like 2,500 years. But I think it's interesting. I find it interesting that BMLSB 69, after that video came out and it got grabbed onto by the Flat Earth, specifically Nathan Oakley and Quantum Eraser and 10th Man and them, that the video got taken down. The day one Zoom footage got removed, and then the video got put back. Actually, it was first introduced by, I believe, Anthony Riley, where he played it backwards. He has a problem with cherry picking, so he claimed he didn't stop the video short. So he played it, but what he did is he played it backwards and never got to the day one Zoom footage. So people went and saw that video on BMLSB's channel and noticed that the beginning of the video shows a normal refracted scene, one you'd see every day. And then he came back on day 2 or whatever days he came back, and then that's when you get the black swan. And then Quantum Eraser and Nathan Oakley got a hold of it and turned it into a whole, big deal, which it pretty much died in its shell. It was debunked within the first 5 minutes.
Allow me to defend that. Well, I'd say, while all that was happening, Dr. John D, PhD, and I believe spectrum, light basically, had a black swan already posted with the windmills. He did so many observations, and he's so studied, and he was able to predict the horizon with the tides in the weather forecast. And so he showed the horizon like 10 times the distance, maybe even more than that, because you can't really tell where it ends with HD quality. oh, I mean, you couldn't show anything better. So you could watch the video or take still shots. And Taboo Conspiracy, Heath Carmody, I mean, The Plain Truth. I could go on and on, even Ranty. If captured black swans, it's just basically an argument, because the whole time we were telling y'all that there's no set place for the horizon. Y'all were doing calculations back then to measure how much something was looming compared to the horizon. And black swan shut that down. If you did notice one thing, you notice nobody says how much something's looming by doing calculations from the horizon, because the whole time we were trying to prove that the horizon is not a set place. It's just optical and nothing more, nothing less. It has nothing to do with Earth curve.
Well, but it has to be physical to be optical. You have to have a physical thing for it to be in an apparent position. You can't have something that's non-physical show an apparent position due to refraction. But anyway, back to the black swan. And then Quantum Eraser got a hold of it, and he said, well, hey, since he created the modus tollens, where every measured horizon has to be 1.2 times the observer's height in feet, whatever, right? But the problem is that nobody on Nathan Oakley's show, Quantum Eraser, 10th Man, Elijah F., Nathan, nobody has measured to that horizon. So the black swan doesn't even meet the black swan modus tollens as valid. It's never been put through the scientific method. So it's not valid evidence in a scientific discussion, as per their demand that everything that's used in a discussion must be put through the scientific method, or else it can be dismissed. Now, Quantum Eraser got a hold of it and said, well, see, now, since we think the horizon is this far, then multiply that times whatever, and it means the Earth is now 24,000 miles or 250,000 miles in diameter or something like that. And then
if you do the math,
he came out with another one. He came out with another one that showed a even worse refraction, and all of a sudden the Earth is like 1 million miles in diameter. So I ask again, does the size of the Earth change with the weather?
Let me butt in, Shawn. You're getting a little long-winded, man. Let me butt in real quick. I want to say that it's your model. That math is not that hard to do, okay? But you done made me forget my point. You kept going on and on and on. But the black swan, there's plenty of black swans. Okay, so that black swan, oh yeah, this is what I wanted to say. Science is not a what is. It's a how and why. It's cause and effect. You don't science measurements. Like if I'm going out, laying out measurements and measuring up a job or something, is that science? No, that just goes speaking for itself. It's measurements. Science is what is. I mean, as a how and why. So it explains cause and effect. So that's where you're mistaken. And with the black swan, are you to tell me that the fire boom, the one that's bent, that's the one that has the exhaust? And I would attribute the hot air to causing that bending, but it's bending downward. So are you telling me that that the crane is where it's supposed to be? That bent arm is closer to where it's supposed to be than the rest of the oil rig, because it's down lower and the rest of it's up higher. So what's had to happen is the horizon that's blocking it a little over halfway up has displaced itself, instead of what we see in reality, like in Skunk Bay, where we see everything go up and down in the distance. I mean, it varies a little bit, but for the most part, we see everything go up and down. And instead of everything out in the focus going up and down, you're saying that the arm to the oil rig went down, the horizon went down and behind the oil rig, and the oil rig went up. So, I mean, that's crazy to even consider that. But 1.22 times the square root of the observer's height in feet is simple. If he was 2 feet, then you just go 1.22 times the square root of 2. So that's your horizon distance. And then if you base your radius on that, it gives you a radius bigger than Jupiter.
do we have atmosphere? Atmosphere refracts, and that's a heavily refracted, heavily distorted image taken from a video that was edited dishonestly to remove evidence that debunks the black swan.
What about John Dee's PhD, flat earther, his lighthouse? I mean, his windmill. He shows a horizon about time further than it's supposed to be. In fact, you can't even see where the horizon ends because it just goes off into infinity. It's a super clear day. And here's my problem: is when I go out and do videos over the water, especially. I mean, I could tell pretty much what I'm gonna see. I just hope for no refraction, like no inferior mirage, because that's usually what we see is inferior mirages. That dominates the horizon. But you know, you get good at it and you can see the inferior mirage. But normally, with the untrained eye, you have to zoom in to even, you don't even know there's an inferior mirage to just any people looking out the horizon. So YouTube has spoiled people into thinking we see like with these zoom lenses when it's not the case.
Well, a lot of times with like a P900, P1000, when you zoom all the way out, you're zooming to a wide angle. It's a wide angle. It's a wide angle and a telephoto. You go from wide angle to normal, then to telephoto. So somewhere in that range is normal vision, what we'd see with our eyes. So you can't go by what we can't see based on a P1000 zoomed all the way out.
So are you claiming that the oil rig is looming? I mean, is that right?
I claim that there's heavy refraction in that video, and it's not evidence for anything but heavy refraction.
What conditions are necessary for to see that?
An extreme difference in the temperature between the water and the air.
An extreme difference. So you're just going to say a difference and leave it at that, huh?
Yes, an abnormally high difference in temperature.
This is exactly why.
And atmospheric pressure takes a part and plays a part in it too.
So your answer to what allows us to see the unobstructed oil rig at that distance is just temperature differential and pressure differential. So this is exactly why science needs to fund people to go out and update this information, because it's not as predictable as people once thought. If you just want it to match your model, then keep going with what you got. If you want to, record reality, then we need to put some more people out there. I think Travis was trying to get something going, and he made a good case, and nobody backed him up. No Globers.
Oh, Travis, in a live stream, I can't remember if it was on Jim's or Jose's, or might have been Shawn's when he was still doing them. But someone offered Travis Finley a blank check. All he needed was a game plan. Give me a game plan of what you'll be using the money for, how you're going to do it, what your research is going to be like. Someone offered him a blank check, unlimited funds for the most part, and he turned it down. Travis Finley is not looking for evidence. He's looking for ambiguity, because that's all he has. He has ambiguity. It could be this and it could be that. He doesn't want any definitive answers, or else he would have taken that check and he would have taken the time to collect the data.
What Travis has done is pointed out everything that doesn't match. So I got to ask you, man. You just saying? Can you give me citations? Hold on. Can you pull up any? Hold on. Can you pull up any citation to back up what you're saying about this looming and what causes it? Or are you just you're just putting that out there?
It's physics. I mean, Google looming. Whatever it says there, that's what I'll be citing. I mean, it's known demonstrable physics.
This is the attitude of a baller.
We understand refraction, man. We understand refraction. You're not
No,
going to present
you
anything
understand
new.
the model. That's a massive appeal to consensus. You're basically just saying, just Google it, and that's your answer. That's the problem. That's what all you Globers have. And when we go out and take the time and the effort into showing that it's wrong, okay, and getting to the bottom of it, let's just say whether the Earth winds up being a sphere, there is bad information. And I don't think you're going to be able to pull a citation anywhere. Andrew Thomas Young is the foremost in the globe refraction model, and he couldn't even explain this. I mean, he doesn't even try. It's like this science is out of date, to say the very least. And
No.
I don't know. And
I mean, if refraction didn't work the way we expect it to work, the way the model says it works, and the model is basically just a measurement, just a catalog of all the measurements and all the things we've done. It's not like a globe. It's not a physical thing you can touch. It's just a representation of the data. That's all a model is. And if refraction didn't work the way that the model says it works, things wouldn't work
be a
right.
globe. Exactly. Welcome to flat Earth,
No.
man. If the refraction didn't work the way y'all said it did, then the Earth ain't a globe at 3959.
No, if it didn't match the model, then things wouldn't function correctly that rely on refraction or optics. It's all well understood, Brian. You're not going to come up with anything new.
So you admit that you don't know, though, right? You admit you don't know. You just say I can Google it, and that'd be my answer. So you admit you don't know the conditions causing it, right?
Not offhand, no.
Okay, well, try to quit being so genuine about your responses when you're just appealing to consensus or authority, basically. Appeal to authority. I mean,
an appeal to authority or appeal to consensus is only a fallacy when that authority is not recognized as an authority. Doesn't have any credibility, doesn't have agency.
So
if I make an appeal to what science has proven, or not proven, but has established, and what mathematics has established, and the things reconcile, that's not an appeal to authority.
Well, what do you call it when I ask you for a citation or ask you to tell me the conditions necessary, and you say you don't, just Google it? That'll be my answer. That's the problem. We've Googled it. We've read Andrew Thomas Young. We did it live. We went over it more than once, and some of us probably a few times. And then Travis has talked to him, and he has nothing. He doesn't have explanations. I don't think that's what you're failing to understand. There's conditions weren't considered. Like I said, when this debate first started, y'all were measuring the looming by how much it was above the horizon. That's what was so important about the black swan, is it pinned down the argument. It pinned down the argument where you can't just say looming and give us a measurement of how much it's looming based on the horizon. And
let's see what Travis has to say about it. Let's call up go to Hyperphysics and open his article that he posted on the website. Let's see what his article has to say about it.
I'd say this, man. Travis is honest, and he's come up with a term because it's something that hasn't been explained, basically. I mean, adequately, and he has proven beyond any shadow of a doubt that these different effects happen in all climates and all temperatures, man, all times of year, and there's nothing set about it, man. The globe model of refraction is mathematical to maintain your model. You almost said it earlier, and I mean that doesn't prove it's not a ball, but at least see that as truth. That's a fact.
Well, let's. I'm calling up Travis Finley's paper that he submitted. Oh wait, it's a dead link. You know why it's a dead link? Because what he posted was peer-reviewed by PhD physics professors and found to be wanting.
By who? Don't just say peer. Don't just
By
say
the-
peer. I want
by the
information.
Department of Physics. By the Department of Physics that
That's
runs
not a person.
hyperphysics.
That is not a person. I want to know the people who went against, and I want to know what they disagreed with exactly, because he left it very general and easily provable. The stuff he was said, it's not. You
have to
can't
talk to
contest.
them.
The stuff he's showing are just observations. There's no contention with observations. So he's very, very careful in making any claims. And for peer review, that's just another example of how biased peer review is you can't even just post a paper about your observations if it doesn't match their model. And I think you know that.
Well, you'd have to talk to them about that, but I'm sure you can go to the hyperphysics website or go to the roster. I'm not sure which university that runs it, but you can go to their roster, talk to the physics department, and find out why it was rejected.
Everybody told me that you trolled that website, and that's why it was taken down. So you
No, I
obviously
told them.
you've obviously invested a lot of time and effort, and even knowing about this and knowing about it. So maybe
Yes,
they're
I
right.
did.
Maybe you trolled the website.
Yes, Travis. See, when Travis does his flat earth stuff, he looks completely different than when he had his discussion with that one guy, the older fellow, guy that gave him the permission to post. See, that guy doesn't own the website. It's the university that owns it, and he just sort of he's a mod for the website.
Why would you
He
get
said, yeah,
involved, though?
post
I'm
your
just asking,
paper.
why did
Because
you get
I don't
involved?
like liars.
Oh, so did you read the paper, Shawn?
Yeah, I did.
Okay, and
Yeah.
tell me, give me three
He changed
lines.
stuff. He changed
Give me
stuff.
3 lines. on
I
his
can't
paper.
remember what they were. Can't remember.
Give me
what they were.
one lie. You're gonna call somebody out is lying and
But-
sit there and get their shit thrown out.
Travis
I wanna know
misrepresented
one lie.
himself during he misrepresented himself during the interview. Completely changed his where he normally streams from to make him appear to be
He misrepresented himself. What does that have to do with anything?
an intellectual. He tried to look like an intellectual. When the guy said, "Well, let's talk about curvature,"
Intellectual, bro.
We'll come back to that. We'll come back to that. And never did come back to
You
it.
just make another claim. You're making them one after another. What did you do to act like an intellectual, please?
He did his video in front of a shelf of books, removed all flat Earth paraphernalia from the scene.
So having a master's degree doesn't qualify as having intellect?
He has a master's degree in what?
Don't worry about it. He has a master's degree. That's
And-
irrelevant. It's refraction. How about that?
Theology or something like that? Theology or something? That's not science.
Doesn't matter, man. What's your definition of an intellect? You are calling him a liar for
Someone
acting
who
like
understands the information
acting like he's smart.
that he's confronted with. Someone who
here's
isn't
why-
intellectually dishonest.
You keep saying dishonest, and you won't give me one example of information that's wrong, and you won't be able to, and that's why I asked.
Well,
you're not going to.
his main deal is
observations, nothing less.
His main deal is there is no Earth curve. It's all refraction, all miraging. That's the big lie right there,
That's
man.
not in the paper, bro. That is not in the paper. You're making shit up, bro. Why would you do that, bro? I mean, that's why I led with the video, the little short video. I was just poking at you a little bit, but I just wanted to show what you do when you're discussing. You just make shit up, bro.
I was asked why would that moon wave happen, and I said, well, he lives near an airport. He's got planes flying overhead.
He's only got one.
I discussed it with some people, and he said, no. Well, sometimes with digital cameras, you get a scan error, and you get scan lines that travel down.
Lunar wave, bro. He's only got
No.
one. You said you
Okay.
debunked it. You could time his lunar wave phenomena with planes taking off at the airport he lives by, but you don't know where he lives. And if that was the case, I mean, he doesn't even claim what it is. He thought it was airplanes too at first, but he encouraged other people, and since then other people captured it, You saying they all live near airports, and it just happens with one special plane
well,
every now and then?
I was wrong about the heat signature then, or the heat wave. Turned out to be
Fair enough.
scanning
Can't cause a couple.
in the camera.
But-
So.
I don't know what lunar wave is either, but
the moon doesn't wave, or else we'd see it every night, man.
Yeah,
We
my
got
whole point is,
thousands
if it was airplanes, we'd
of
see it
people
every
who would
night,
see
right?
it.
Would you agree that if it was airplanes, we'd see it every night, if it was common?
Well, if the situation was perfect.
I live near an airport. I've been trying to get it for 4 years, and I haven't got it yet. I haven't been so lucky.
I was saying that's what it looked like to me. It wouldn't be
That's
distinct.
what we get on a clear day. On a good clear day, if not
clear
very
horizon.
common, but on a good clear day, with no inferior mirage, which, like I said, ain't very often, but you get exactly that. That's our point. There is a horizon, and it's hard to find. It's hard to find days like that. They're few and far between, but they do exist.
During times of low refraction, of standard refraction, you get a crisp, clear horizon. You don't get any distortion in boats going over the horizon. You don't get any compression. You get a crisp, clear cutting off of boats from the bottom up. That's the white
You've got
swan.
no way to prove that.
That's
bro.
what we see every
No,
day.
that's
And
only-
you and I have no way to prove
That's
it.
big.
We've shown you the photographs, man. What about
Listen, man, the reason
the
there's-
sailboat
Hold on.
picture that Travis Finley refused to look at?
No, look, I'll look at it, but the reason there's not a million boats that are cut off, there's several, but there ain't as many as you would expect, is because usually there's an inferior mirage, and it's easily, so they're getting these in the middle of the day, and we're going back in the evenings and the mornings when the sun ain't beaming on shit, and often seeing different, a totally different scene. The horizon is nothing more than an optical position, man. It's nothing more.
Of a geometric shape, of a geometric
No matter what
thing.
the shape of the earth is, the horizon is what it is. So even on a flat plane, and let's say if you're up at cloud level, okay, and you're looking off into the distance, okay, let's say you're above cloud level, and you can see where the blue turns to black at about what, 12 to 15 miles, let's say 15 miles. Okay, what you're seeing on a flat plane is that 15 miles compressing into the distance. So the horizon is a function of distance. So however clear the day is, that's how far you're going to see the horizon, and it depends on the clouds too. But it's just a compressed zone. There's nothing else to see, so you can't see any further. It's just compressing into nothing, basically.
Let me ask you a question. Let's say you've got a buddy that's half a mile away, or he's far enough away that you can still see him, and he's holding a ping pong ball. And then about a third of the way between you and him, there's a car. Now, do you think you'd be able to see the ping pong ball?
How far away was he?
Let's say 200 meters.
Sorry,
Yeah,
Shawn,
yeah,
Shawn and
absolutely.
Brian.
You'd be able to see the ping pong ball that he's holding in his hand.
Sorry, Shawn, Brian.
What's going on, Keith?
Sorry, we were down for almost 10 minutes because my phone died, so I had nothing. Luckily, it was recording.
Oh.
So we'll just go on another extra 10 minutes of open dialogue if that's right with you guys.
Okay.
Okay.
Yeah, I'm
Okay.
not done anyway.
Cool.
So you got a
10
ping
more
pong
minutes,
ball,
I'm good.
right?
Yeah.
He's got a ping pong ball, and he's far enough away that you can still see him, but he's real small. So would you be able to see the ping pong ball that he's holding?
That
Probably
he's
not,
holding.
right? Yeah.
If he's that small, I guess if you're invoking Rayleigh criterion, then yeah, once it gets under a certain size, we're not going to see it.
Right. But you can see the car that's in front of him, right? About a third of the way there.
Yeah, sure.
Okay. Now, replace that car with a mountain, and replace that ping pong ball with a pinpoint of light. That pinpoint of light is a star on the flat Earth dome, the container, all the way across. Like if you're looking north, or if you're looking west, it's the star. It's at the horizon, way, way, way out past that car or the mountain. But yet, I can't see Mount Mauna Kea. It's in Hawaii, 2.5 mile tall mountain. I can't see that. That's between me and a tiny pinpoint of light that's on the horizon. Why is that? Why does refraction work the opposite on flat Earth or perspective? Why does it work the exact opposite on flat Earth? Why do big things disappear first before teeny things? See, on a flat Earth,
Bro, we can't.
you should be able to.
Okay,
I should be able to see
let me
Hawaii
respond
from
to that.
California. I should be able to see Eugene,
we
Oregon.
can't see anything on the horizon. There are
From
no
here.
stars. No stars are visible on the horizon, bro. I don't know if you've ever tried to record them.
Yeah, they're visible. Very, very faint, but they're visible. And they're about a degree above the horizon.
No, they're not.
So,
They vary. They vary, showing up between about probably. This is my guess because I can't get it exact, but in my experience, they average showing up about, a few of them will show up about 2 or 3 degrees, just a couple, not many.
Okay.
And then
2 or 3.
and the majority of them start showing up around 4, maybe 10 degrees, between about 4 and 10 degrees, but different stars show up at different times. It's not
Now,
as
if you
clear
could
cut as you
actually-
think, bro. And when we get up high,
if you
you
could
can't even
actually-
see the star.
If you could actually see a star that's right at the horizon on the, that's plastered onto the dome, if you could actually see it, would it be any further away than the one that you see at 3 or 4 or 5 degrees above the horizon? Probably not, right? Be the same distance, same angular resolution. But yeah,
I'm saying, what's
I can
stopping
see
us?
that
What's stopping
star
us from
that
seeing
far
that,
away.
bro?
I can see that star like 6,000 miles away, but I can't see a 2,000 or a 25 or 2.5 mile tall mountain that's only a third of the way there. See, on
Bro,
a flat
the
Earth,
world
you
record.
should be
Hold
able
on,
to
the
see a
world
lot.
record photography is.
When you say, let me conclude by saying this. When you say that we see too far, no, dude, we don't see far enough if the Earth is flat. We should be able to see a lot farther. I mean, a 500 tall, a 300 foot long or 300 foot tall boat that's out in the ocean, the angular resolution, it'd have to be 250 or 500 miles out.
Bro, you're
to be able
thinking
to
in 2 dimensions.
not be resolved.
You're literally thinking in 2 dimensions, bro. Look, here's the point. The point is the world record photograph. Hold on. The world record photograph is a mountain. He took it from 1,000 feet, I believe, and or 2,000 feet. He's up there a little ways out of the bullshit. He could see a mountain 270 miles away, and you could see a couple a little closer than that. It's a speck. It's literally a speck, bro. And you could see the land really going off even further into the distance. It's just compressing, bro. So here you have a mountain that's a couple miles tall, okay, that's supposed to be hidden by a few extra miles. So we're not even supposed to see the tip of the mountain. It's supposed to be like 3 miles under. So it's literally supposed to be above him. I mean, basically level with him. I don't know how you can explain it, but my point is that mountain is a speck in the distance. So that's about the limit to vision. But with the horizon limiting,
with
how
a
far we can
camera,
see, that's like a 2015
with a
argument.
camera, you zoom that in.
That is
right?
zoomed in.
Okay. I'd have to look at the picture,
But you're thinking of things in
flat
2
Earth,
dimensions,
you
bro.
should be able to see further.
Let's say this: taken on the ground with thick paint, so it leaves a little bit of an indentation, like almost like braille, and you draw a big giant 1, and then 2, then 3, then 4, then 5, and you just keep drawing these thick numbers on the ground. By the time you get to the horizon, whatever number that is going to block any numbers behind it. But I mean, how do you imagine seeing these numbers going off in the distance? You think there's enough room in it with a 2-dimensional picture to show a million numbers? It's just not possible. You have things competing for space, so they just mush together, man. That's what a horizon is.
Okay. Whatever you say, Brian.
Okay, so yeah, in about 5 minutes we're going to go to Q&A, so everybody can get their questions ready for the guys. Remember, all super chats will be pushed to the front of the queue. So yeah, 5 minutes left.
I'm ready for Q&A now.
Would you agree that would you agree the horizon is a convergence point, basically? Like we could get a horizon in a hallway and out at the ocean. I mean, there's going to be different horizons, but horizon's basically just a type of convergence point of a person's location. Would you agree with that?
Yeah.
So if we can get a horizon in a hallway, and I'm glad you did, because I would have asked you you know, what's taking up the picture, the entire picture, the ground or the sky. Because the horizon is just a function of distance. So if you have railroad tracks converging in the distance, and then you had parallel lines spreading out from the railroad tracks, just a bunch of parallel lines, they don't converge equally. And it's the same thing with the ground in the sky. Things don't converge equally. The things up higher converge at what appears to be a quicker rate because things are shrinking in the distance. Your optical corridor is literally shrinking.
No, not in the sky. Polaris doesn't shrink at an uneven distance or drop at an uneven distance. It drops in a linear function to it's the distance you are from it. The angle and the distance match. That's linear.
I'll say it does when it's overhead.
That's because it's on a sphere. Now, if you take that, just like I showed in GeoGebra, the angles don't match. That's nonlinear. That's flat Earth. Flat Earth is nonlinear. Curved Earth is.
That's why I made that equation, bro. It's refraction. Okay, here's the point. Up overhead, the star. Hey, if you had a freaking mount. What do you call it? A celestial mount or a EQ mount. So you had an equatorial mount and you were having problems with it, bro, because look, you were probably trying to look on the horizon. And the fact of the matter is when the stars hit about 30 degrees, they start slowing down. We've demonstrated this over and over and over again. And
because of refraction. That's why we
you're
don't.
You're going to claim refraction, but you're saying that it's linear.
We don't try and track stars near the horizon.
So that's 60 degrees out of the 180 of our full circle of vision. That is non-linear, bro. So if you're claiming it's linear, that is preposterous, man. It might be linear above, like directly above your head, and off a little distance, but it's everything but linear.
Because of refraction.
Yeah, and I'm telling you why on a flat Earth. It's not linear. It works that you don't get 1 full degree of deviation until you get a little over 1,500 miles. It's like 1,550 miles. That's when you get your first degree of disagreement.
Did you notice all the numbers on the right side of the decimal point on all your angle measurements, Brian? They weren't even.
They're all 69 miles per degree.
No, they aren't.
Yes, they are.
No,
Guess the difference.
Less and less and less.
No, it's not.
It wasn't an even number. You had a bunch of decimal places.
That's literally. You just described my point for me, bro. I got no problem with that. I told you how it goes off, and I told you why. So you can have refraction in your model, but not me, right? That's how it works.
No, see, your refraction formula is nonsense, Brian.
No, your model is nonsense because
you can't demonstrate. You know it.
Right? Remember when I asked you?
Refraction formula has been debunked.
Remember when I revised it and it hadn't been debunked? Remember how I asked you to show me? 7/6R has been debunked because I asked you to show me one demonstration of light behaving the way the model claims, and you can't. You know why? It's simple.
Is it a nice day?
Light doesn't.
Is it a nice day? Look outside. That's standard refraction. A nice day is standard refraction.
Then you should have no trouble showing it, right? Right?
You want me to take a picture outside?
I want you to show me light behaving in a 7/6R fashion. Don't just show me something in the distance. Say, Steve, not where it's flatter than it's supposed to be, so 7/6R is proved. No, show me light behaving the way the globe model. You can't because it simply doesn't have.
You want another piece of evidence that you can deny, Brian. That's all you want.
I'll take one. Don't give me no.
We've shown you a mountain of evidence, Brian, and you denied that it's there. We've shown you a mountain of evidence, Brian. As a community, as a globe community, we have presented you and every other flat earther with a mountain of evidence.
Then show one.
Terabytes of video. No, I'm not going to show one. Because all you're going to do is deny it, Brian, like you've denied everything else that I've said here. I'm done.
I'm freaking out on me
I'm
again.
finished with the Q&A, man. You've done nothing but deny everything that's been presented.
Tell me when I can respond, bro.
Okay, 3 minutes.
Don't interrupt. Just don't interrupt me. Let me make an explanation. Our phone's getting problems. But before we end, I wanted to make this point. Okay, you say you won't present even one of your mountain of light bending downward. Okay, not even one, because I'll just deny it. How can I deny light bending down if you show me? If I can see it bending down, like what I showed you in my opener. If you didn't see it, you need to go back and watch it. I show you light.
Okay, play your video.
I show you lasers.
Play your video that shows laser light bending down. Because you showed it, Brian. You presented that yourself. That's as part of your evidence. You presented light bending down.
I literally presented.
There you go. You debunked yourself. If you were expecting me to present you with evidence to debunk you, you've done it yourself.
So, listen, my phone's freaking out. So, can you show me one picture of light bend? That's all I need is one, bro, to see that it could even possibly do with what your model claims. Y'all have never shown it, bro.
Flatzoid, play his video. Play the sugar water tank with a laser. There you go. That's my picture.
Bro, I can see the bottom.
Your evidence is my evidence, Brian, because it was great evidence for refraction.
Okay, so hear me out then. Don't interrupt me, please. Okay, there's a rim around the bottom of the tank. His picture is above that black rim. So the only time we lose the bottom, which would be the shoreline, is when he gets down to the bottom, and we've already lost 3/4 of the top of the photo. So we've still got line of sight, yet half the city's gone. The 3/4 of the city's gone with line of sight. So all you've done is proved refraction on a flat plane with line of sight. You literally showed half of the buildings gone with line of sight.
Are those buildings inside the tank, Brian?
The buildings are sitting on that.
Or are they outside of the tank through a change of medium?
Sitting on that lip, and that lip never disappears until compression happens. And there's no way to get a picture underneath that rim, because that rim goes all the way around the fish tank. So he'd have to put his camera inside the fish tank to show a picture not line of sight. So that little curve he's got in there, I showed in the video where it's underneath the lip that goes around the fish tank. Everything in that video is dishonest, and he still proves a flat earth, bro.
Okay, and that's
how far? What is the air gap between the end of the tank and the picture? Is the picture right up against the glass of the tank, or is
it's sitting on that lip? I don't know. It's sitting on that lip.
Is touching the tank. The picture is touching the tank, or is it a distance from the tank?
Okay, guys, that's time.
There's a black.
Unless you guys still want to go on for a few minutes, doesn't matter to me.
If you look at the thing from the side, is there a distance of space between the right side of the tank and the picture?
No, I don't think you're hearing me, bro. There's a lip.
No, you're not answering my question. Right, I know there's a lip around the tank. I know that.
So but can we call that
the picture in proximity to the tank, Brian?
Can we call that lip the line of sight? Anything above that lip?
Call it the horizon.
It's the line of sight, though. So anything above that lip that's going around the full fish tank is above line of sight. Is that fair to say?
It's above the horizon of the tank. Line of sight was above that line, Brian. Line of sight is straight forward from your eye line.
That lip, bro. If I can't even find mutual ground on the fact that the lip is line of sight, then I don't know how I can continue, bro. It's this simple shit.
You haven't answered my question, Brian.
Bro,
is there a space between the right side of that tank when you're looking on it from the side? Is there a space between the right end of that tank and the picture?
Bro, you haven't even seen the video, so I'm wasting my time.
Is there a space between the right side of the tank and the picture? Yes or no?
Bro, you're already just making stuff up. Why are you trying to talk about something?
The light coming from the picture would have to go through one medium and then into the tank that's been put into a refractive state.
Hey, before
So
this
you're
ends, I need
looking
to
for another,
wait.
section of
How do
medium,
you
Brian.
fit inside the crater of the moon? I've been meaning to ask you that. How do you fit
That was a
two
joke,
Earths
Brian.
inside the
That was a joke.
No, it wasn't. It wasn't funny. You
It
didn't say ha.
was. It most certainly was. It was bait, Brian.
What
And
was
none of
funny
you could
about
even debunk it. You couldn't debunk it. You discussed it like it was something that could be factual. That's
okay,
the
why
funny
did you,
part.
why
That's
did
the
you
trap.
make the definite claim? You said you debunked Crow's footage because he lives near an airport and you can time the
I said
airplanes
that's
leaving.
that's why it happened.
Why did you, bro? I'm asking, why did you make the definite claim that you debunked it yourself? You claimed you debunked it, and this is how you did it, by timing planes. Why did you do that?
I said that's what could be one of the causes. And since I didn't have any more data after that, I stuck with it. And then I discovered later, after doing more research, that no, it wasn't that. It was a digital
So is that
thing
a
in
formal
camera.
contest?
Okay,
I'll
1 minute,
accept that.
guys.
Yes, I was wrong about the planes.
Fair enough, man. Thank you for that.
Mm-hmm.
Okay, so I think
I
we can
I
go.
enjoyed it.
I think we can move on to the Q&A if that's okay with you guys.
Sure.
Great discussion, by the way. I have to say, you guys are on a ball.
Yeah, I've enjoyed it.
Yeah, I'm enjoying it too. Yeah, this is your guys' chance to get some questions in for the panels. See what their answers are. We got a few of them already, so yeah, let's get started. The first one, the plain truth. Ask Shawn for all the evidence for his slander against me.
Wait, I didn't catch it.
The plain truth is from Travis. Ask Shawn for all the evidence for his slander against me. So he's sounds like he's looking for the evidence.
What's slander?
You called him a liar, and you said he's dishonest in his paper. At
Yes.
least explain a little bit.
It is dishonest. His dishonesty was discovered by peer review.
Those.
So how did you know so much, man? You must have got involved, right?
Mm-hmm. Yeah, I called the university and told them to actually
and
look
you,
at
you
what was
slandered
presented.
him, right? And you slandered him, right?
No, I said
Shawn,
look
why
at
are you,
look at the paper.
Why are you lying, bro?
I described what happened, and I said look at the paper. And they did, and they found it lacking.
What? You called them just to tell them to look at the paper, Shawn. Shawn, do you think it's okay
Yes.
to just say anything at all and just, don't you think it's bad to just lie?
I don't lie.
But sometimes when you lie, it's so obvious. Sometimes it ain't, Shawn, I'll give you that. But when you say shit like that, you called just to tell them, hey, look at the paper. No, you
Yes.
called to slander Travis, bro. It's no secret. It's already out there.
No.
And
It's not
and you can't
slander
even
if
get
it's
one
true,
reason where he
Brian.
lied. You call him a liar, dishonest. So at least say one thing in his paper, not about him, about his facts, that were dishonest.
Okay. So next, Lumpy. Oh, where's Brian? Did he drop? Oh, there we go. Brian's back. Okay. On to the next one. So from Lumpy Gas in a Vacuum. Where did Shawn get his 90-degree angle to Polaris?
It's a commonly known angle. That's established fact.
Okay. TB. Ask Shawn if he has a line of sight to the horizon.
Yeah. If you can see it, you have a line of sight to it.
Okay. Lumpy Gas in a Vacuum. It's more of a statement. Shawn is hijacking FE facts and claiming them as proof for the globe. What the heck?
No. Not doing that at all. Cool story, bro.
He's passionate. He's passionate about his stance, man. But I think he's dismissing some things. Maybe some things are okay, but there's a lot of things I believe you should try and see with a fair, unbiased eye, and because it's hard to talk to somebody when we show you something and you deny what we're showing you point blank. Like, it's weird, kind of like, here it is, see it, let's talk about it, and then you won't even get past seeing it. It's hard to progress.
Okay, and then we get from Soundly's Banana Cam. How much does a rainbow weigh? Not much. They're actually pretty light. I think that's to Shawn.
Ah, funny.
Shout out to Is that Santos Bonacci?
Soundly's Banana Cam. I'm not sure.
Oh, okay. I'm about to say.
And TB.
What?
Just ask Shawn for the R in 7 of 6R. So he's looking for the radius. The question is, where's the radius in 7 of 6R?
And measure.
Can you repeat that?
Ask Shawn for the R in 7 over 6R. My question, where's
And measure.
R?
It's measured by spherical excess.
Okay, spherical axis. So, Jonas Zen, ask Shawn what refraction is.
Refraction is the displacement of light due to light traveling from one medium to another, medium of density or a physical medium that is denser.
Okay, and then we got another one. Shawn, you need to demonstrate light bending down without using sugar in a tank, since the atmosphere doesn't consist of sugar. That's from Derek Nelson.
Right, but the atmosphere is provably less dense the higher up you go.
Okay, and again from...
It's because the pressure. So the pressure goes down, and I thought that the air was measured in pressure. I didn't know that it's measured in density. Is oxygen denser or the nitrogen? What's denser? What molecule?
The denser the air, the heavier the air. What are you talking about?
I mean, dude, it's only basically one medium. You know, it's homogenized. I mean, it's non-homogenized basically. So it's just a freaking just the air we breathe. It's the air we breathe, bro. The pressure doesn't go down fast enough to cause any refraction. That's almost like saying there's refraction in a vacuum. It's just a little bit more, molecules for that matter. I think you have to have for noticeable refraction, you have to have some type of difference in medium. Like I think water vapor fills the criteria of the difference.
Density of medium.
It gradiates down to nothing at about just a little above the clouds to thickest at the ground.
That's why we have less refraction on mountaintops.
Okay, Derek Nelson again. A 90-degree angle requires a flat surface on the bottom.
Cool. Someone paid attention in geometry.
Again.
What's the question?
I think he's just more a statement about the 90. It requires a horizontal baseline.
Yeah, I think he's making a point.
You mean
yeah,
like we
you want to respond or elaborate, bro?
We can't have a line perpendicular to a sphere. I think that was for me, wasn't it?
Yeah.
You can't have a line that's perpendicular to a sphere. That's 90 degrees to that sphere.
You can, as long as you acknowledge that all your measurements are brought down to a chopped in half globe, a flat plane. For the angles to even correspond, they all have to be brought down to a plane in a point in the center of Earth that measures like a plane, and you have to call the surface two-dimensional. Also, I've recently found out that the celestial sphere is also two-dimensional. So how do you get from 2 dimensions straight to like 4-dimension space-time BS? You're just skipping the whole entire dimension, bro.
The surface of a sphere is 2-dimensional, but the sphere itself is a 3-dimensional object.
Okay.
There's no 3-dimensional surface can't be 2-dimensional, I don't think.
And yes, the surface is 2-dimensional. There's no variation between the radius, between the center of the circle and the edge of the circle. or the sphere. Sorry.
Can you name the two dimensions?
No difference.
Can you name them two dimensions?
Height,
Because
width.
what you need to have a surface of a sphere, you have to have length, width, and height. That's the three dimensions that are necessary to have the surface of a sphere.
No, that's to have the volume of the sphere. The surface.
You can't have the surface of a
surface of a sphere. You can go forward and backward. You can go left and right. You can go diagonally. You don't go up away from the center of the sphere. If you're on the surface of that sphere.
So you just said it. So the center
higher
of the
than the
sphere,
surface.
right? So your elevation is determined by the center of the sphere. That's by definition three-dimensional.
Your elevation doesn't change anywhere you go on that sphere.
According to the center of the sphere. Once
The
again,
elevation
that's
is
by
the z-axis.
The elevation would be your
z-axis
Don't even realize
in a Cartesian coordinate system.
Okay, so TB. So if Shawn has a line of sight to the horizon.
Let me. I wanted to say something. I got interrupted when I was trying to. About this 90 degrees from a sphere. You can measure 90 degrees from a curve to a line if you measure it very close to where that line intersects the curve. And that's how you measure 90 degrees from a sphere or any angle from a sphere. Now, when you take a sextant reading, you aren't moving your line of sight down to the water. You are creating a horizontal line between your eye and straight out. And that's where you're measuring up from. You aren't measuring the surface of the water or the surface of the earth.
You're going
That's not how a
beyond the
sextant
surface of the
works,
water.
okay? So
do not
just
do
wanted to get that out.
calculations on the surface of the sphere. You do calculations down in the center. It does not work from the surface.
No, you prove the math works by cutting the earth in half and measuring from there. That's how you prove the math works, Brian. You aren't measuring from the center of the earth. You're measuring from your eye looking through a sextant.
Tell me when I can finish. Okay, thank you. Okay, now you got to go beyond the surface, and you got to take that calculation down to the center of the earth, or it does not work. There are no calculations done from the surface. The measurements are done from the surface, and then you pre-assume a radius, and you do the calculations from the center, or else they don't work.
No, that's how you prove that the math works, Brian. That's not that cutting the earth in half and moving the parallel line down to the center of the earth. That's only to prove that it works. That's not how we take the measurement.
Do you know how many radians are in a circle, Shawn? How many radians are in a circle?
Not offhand.
Yeah, it's a simple question, bro. So you don't know because I just asked a real simple one. There's 3.14 radians in a circle, Shawn. So quit acting like you know anything about this, bro. You do not know shit about it. Sorry.
Doesn't matter how many radians are in a circle. We prove the math by cutting the earth in half and doing the geometry, or doing the trigonometry on it. But we do not take the measurement from the center of the earth. We take it from our eye out to the horizon. You have to correct for depth by bringing the angle up to horizontal, and then we take that angle to the star based on that horizontal line from our eye, not from the ground, not from the center of the earth, from our eye.
All right, now we're in agreement. Thank you. So you do take the calculations. You take the measurements above the water. The guy asked a question about going down to the water line, or you made a comment. So you go past the water line after you take your measurement. You do your calculations from the center of a presupposed sphere. You have to.
No, you don't.
You can't do your.
You don't
your
take the measurement from the center of the earth, Brian. That's ludicrous.
Didn't say that. You got to listen.
You just said it.
No, you take measurements from. How could you take measurements from the center of Earth, Dodo?
Okay.
That's what you're saying. I'm not. That's your claim, dude.
Guys, ready for the next question?
Yep.
Okay, from TB. So if Shawn has a line of sight to the horizon, then the horizon being over 10 miles away from the observer at 1 foot changes the radius.
No, it changes where we see the horizon because of refraction. It doesn't change the radius.
Okay, from TB again. Is spherical axis a calculation that requires R?
No, I don't believe it does.
Okay.
Main surveyor and can't remember the other guy's name from Michigan. He'd be the one to talk to about that, but don't believe they take R in NPR.
It was, is spherical axis a calculation that requires R?
Of course it does. Everything
I mean,
on a
saying
ball, or how would they know the size of the ball?
So if you want to know the circumference of a basketball, do you have to know the radius of the basketball to measure its circumference? I don't think so.
Oh, but to do any calculations, you have to determine a radius by doing the measurements, and that's not how the Earth works. We do make these measurements; they just don't match the given radius. We have debunked the radius.
Most certainly do. What are you talking about? Your observation of it doesn't match the pure geometry of it. But that doesn't change the science, Brian.
Like I said, your own surveyor.
How you see things is not how things are.
Your own surveyor, the main surveyor, the one you just mentioned, proved that he was off, like I said, by 7 million feet from his Alberuni test. With modern equipment, your radius is wrong.
Okay, Derek Nelson. I can't make light bend down, whether using dense or light air. I think that's for sure.
Okay.
Okay, and then another one from TB. Does Shawn disagree with Andrew Thomas Young that there's never a straight line of sight to the horizon?
Yeah, I can agree with that.
Okay, then Brian's logic. Totally incorrect, Shawn. Height of eye correction is a correction from the eye line to the water line under the boat.
Stop getting your instruction from idiots like 10th Man Rising.
No, he's right. Brian is right. That is
no, he
how
isn't.
do the math.
There's no citation in any nautical or navigation book that says that's how we do the measurement. Dip
So do you bring it up to 39, 60 or something?
Correction
Or
means your eyes
down
are
to 39?
dipped down toward the horizon, and you were correcting for that angle. You're subtracting that angle from the total measurement, Brian. That's what a dip correction does. It subtracts that angle from the total angle. So if you have an initial reading of from the horizon to 41.1 degrees, and the dip correction is 0.1 degree, your angle to the star or the sun or whatever is going to be 40 degrees. You subtract that.
How high
You don't add that.
If you have 1 degree dip angle, how high would you be, Shawn?
I'm sorry, what? You garbled.
If you had a 1 degree dip angle, how high would you be?
I don't know.
Yeah, so quit acting like you do. Brian is right, and 3959 comes from the surface of a sphere, bro, not up above it.
You would that 1 degree dip angle would be
3,600
equivalent to however high you are up off the water. But that angle is not, the angle to whatever we measure is not taken from the water. It's taken from your eye. You don't move the point of observation, your control point, down. That's not how it works. 10th Man Rising, Quantum Eraser, Nathan Oakley, they're lying to you, Brian, because they don't know anything about how to operate a section, how to do celestial navigation. If they did, they would be winning $10,000 from MC Toon, Brian. But they're cowards. They're cowards, and they chicken out of a challenge that challenges their reality because they know they can't win it, because they know that's not how a section works.
You're rambling,
They're
bro.
idiots, Brian.
This has got nothing to do with
complete idiots, Brian.
Just listen. Quit saying idiot and listen. Let me say one thing. Okay, 3959 is the surface of a sphere. So if you don't bring the measurement down to your 3959, you can't apply that when you line it out, when you do the distances, stupid.
And you don't know how to do celestial navigation either, Brian, because you're getting your instructions from liars. Just to prove that what I'm saying about 10th Man being a liar is true, he takes every celestial navigation book and he says ignore every picture that shows a globe. That's dishonest. That's being a liar, Brian. And you're getting your information from that man.
He don't want me to talk. Okay, that's why I posted in my opener me using my model to give MC Toon the correct location. Okay, so don't act like nobody's done it. If you'd watched the opener, this would have been a more direct conversation. But please quit lying. Quit just saying anything that you don't know. You're admitting that you don't know and making claims.
How did you get that location? How did you get your location, Brian? Use spherical trigonometry. Use a spherical source. You didn't do it on flat Earth. I watched that. I watched that debate, Brian. I watched that debate.
Okay, TB.
You conceded that you didn't use flat Earth math to do it, Brian.
Okay, TB.
What are you talking about?
Right? You conceded that you didn't do it the way it was supposed to be done. You didn't. You used a spherical source.
This guy's just
saying, Brian, and we all did.
Just go back, watch the intro, and then we'll talk.
We all watched it.
Okay, guys, I think that's all for the QA. Just one last thing. TB says, Shawn, why do you say there's a line of sight to the horizon? Then you say you agree with Andrew Thomas Young that there's never a line of sight to the geometric horizon.
That's not what he asked. He didn't say to the geometric horizon. He said a line of sight to the horizon. We see the geometric horizon. We just don't see it in the place that it's supposed to be geometrically.
Okay.
You can't have an apparent position of something that's not there at all.
Okay, thanks very much. I think that was a very good discussion. Maybe you guys can come and have a debate again sometime. I really enjoyed it.
Sure.
Yeah.
Yeah, maybe we'll do round 2 on gravity plateau, but I appreciate it, man. Shawn, I do ask that you go watch my the full intro, man. It might clear a couple things up. It might not, but maybe the next we could do this, in the future. Thanks for having me, Plateau.
Sure. I challenge Nathan Oakley, 10th man. I challenge anybody in that cult. Come on here and debate me. Open, fair forum. There you go.
Okay, so yeah, you guys heard it. Nathan, you heard he challenges you, so would you go up to him? It would be great. You know, the channel is here for you guys, for anybody. Just news, tomorrow night, 9 o'clock Central African time, it's Fight the Flat Earth versus me, by the way. Yeah, on science. He challenged me to a debate, so that should be happening tomorrow night at 9 o'clock Central African time. Thank you everybody for coming. Really do appreciate all your support. Please do, I will put links to Shawn's channel and Brian Leake's channel in the description now, straight after the debates. Please do go to their channels, subscribe, and yeah, we'll see if we can get them back again for another debate. Really do appreciate you guys coming for the debate. Thank you, Shawn. Thank you, Brian. You guys were awesome.
Ciao.
Peace out later on, guys.
Cheers, guys. Thank you. Thank you, everybody that was in the chat. Thank you all for coming. Really do appreciate all your guys' support. So yeah, sorry that earlier my phone died and the power. So I think it was like 5 minutes where it was just without sound. But I managed at least to put my wife's phone on, so that helps a bit. It has a recording, so at least that should show when if you want to go back and listen to what they are saying. So yeah, thank you all my Patreon supporters. Thank you everybody that subscribed. Thank you for everybody that's come on here, and just please do hit that like button and share. It really does get it out to more people. And yeah, thank you for all my members. You guys are all really what's spurring this channel on. And yes, I don't know what's more important first. Should I get a new mic or should I get a camera? Let me know in the description below, in the comments below, if you think I should first get a camera or a microphone. Anyway, thank you guys all. You guys all rock. I really do appreciate your support. Hope this platform can work better for you. And like I said, tomorrow night is Fight the Flat Earth against me with Does Science Prove Things? You guys all rock. Till tomorrow night.